Hi everyone, my name is Hung, and this is my friend Hao helping us to talk about our project for the education track in Datathon at RISE 2026. So let's start with the background and the foundation problem for our model. So we're starting off with the background that there are standardized testing framework, whether it's STAR or um, SAT, that is dictate what student must learn for each grade level, and professors must align these curriculums, or teachers also align the curriculum to these standards. But not all textbook being mapped to those specific standards. That is requiring our team to develop a machine learning model that predicts the most relevant standardization score for the textbook section. So with that, we can understand the data by pre-processing the JSON file into a CSV file that being used for hierarchical structure. That is, we organize the code into grade, domain. The grade can determine the domain of knowledge, and the domain can have the cluster of subtopics within that knowledge, that we can tokenize the domain and the cluster columns to capture the patterns in the textbook organization. With that, we can use the pre-processing data to understand how many elements are in the training dataset. Either is titles, sections, and example in the content that could be stored in many items in the domain. So I will pick expression and equation or functions, for example, to visualize our data. Here you can see E and F for the eighth grade or HSN. All further in the left are the grade level corresponding to EE or F as the domain of knowledge on the middle that represent the further right, the subtopic. Like, why does that matter? The reason is this visualization gives us so much about the clues of how the prerequisite of an eighth grade course can determine the high school algebra class being overlapped with each other is a visualization, and this helps us to visualize our problem better. But still, a problem persists, and that is not um, not every class are balanced. There was also a class imbalance for high school or eighth grade, and not every standardization code appears equally in this case. So how do we solve this standardization problem? Our team has developed a model to help us solve this case.
All right. So our model will give a solution for mapping OpenStack's textbook content to educational standard using semantic search. Leverage Google Gemini embedding and MongoDB Atlas vector search to find the most relevant standard or section details. So for how I build it, um, so firstly I would do the standard. I will do the data wrangling. I will load it next to the JSON file, would have four level div books, domain cluster item, and then flatten complex hierarchy into symbol data format. And I also remove some redundant like space and corrector from that. After that, I will use the Google Gemini API for creating connect for creating function to convert text into 768 dimensional vectors would embedded all 173 educational standard definitions. After that, I will get help from MongoDB Atlas with the cloud database to upload 173 standards with their embeddings and create a vector search index for fast similarity queries. And I also build automatically retrieve system to wait for index to warm up. For the capture conceptual similarity, it is because the traditional search looks for exact word, but our system look for shared meaning. The model maps the input in the 768 dimensional vector space where irrational and non-terminating exist in the same conceptual neighborhood. And our system is zero-shot learning allow us to map content to standard the model had never been explicitly trained on. And for the heat map, as you can see, each column represents for the connection. The yellow present weak connection, the orange will be the moderate relevance, and the dark red is strong match. For example, the iron one had 0.92 similarity with a standard of AGC9 volumes. Each row also had one dark red cell, would mean the model is decisive. The model connects convolution to geometric formula standard even though exact would differ. Okay, so why I choose this model over the traditional machine learning? Because we don't need training data model. We don't need to train our data before. So because we just have like nearly 600 example for evaluation, so we don't need to train it. And the model understand the meaning, which means the repeating decimal is rational number. This is semantic concept. And this model also give me the instant updates. So if we have the new standard added, it will work immediately without any retraining. And this model also consistent and transparent because same logic applied to all the test items and confidence score. So it's certainty. What is the confidence score? So I use the top K accuracy for model evaluation. For this, for the model evaluation, for the top one, it will have like 30.9, nearly 31%. And the top three is 57.4%. And the combined will give me like 67%. This is a good number because 60% of human performance with zero training example before. And this is much faster, like nearly 60 times better than random human guessing. So this model is very good.
With a better model that we can solve this problem, what is the certain impact that we planning to help with our education? So it would help professor or teachers are being encouraged to accelerate their academic planning, that knowing to help meet student standard. It also help professors or teachers diagnosing the conceptual difficulty that could be placed as an integrating planning tool for academic planning, and that is also helps with discrepancies, covering the missing gap in our textbook, and ensuring the books comprehensively represents all the required standard for testing. And that is all for our presentation today. Thank you so much for listening.